Hi, I'm your host, Tyler DeWitt, and today we're going to be taking a journey across the Pacific Ocean to the remote islands of Palau. This virtual event is made possible with the generous support of Lowe's. Home to more than 21,000 people, Palau is made up of 250 islands. It's a beautiful landscape of beaches and lagoons, underwater caves, and even the mysterious saltwater jellyfish lake. Palau is also famous for its astounding and beautiful coral reefs, which you'll get to explore today as we dive down into an amazing and interconnected underwater city. Many exotic, weird, and colorful organisms live and also work in this city. Each one has jobs to do that keep the entire system healthy. Here, sharks snatch up smaller prey. Decorator crabs apply bits of shell, algae, and sponge to their own backs for camouflage. And massive 2,000-pound sea cows graze. And the coral itself is a living, growing organism as well as a home. Coral reefs are formed out of colonies of millions and millions of individual corals. Coral reefs exist all around the world. Here's a map that shows where you can find Earth's coral reefs. Palau is an ideal environment for corals to form because they need water that's warm, 70 degrees or warmer, year-round. Guiding us on our deep dive today will be marine biologist Stephanie Weir, who's joining us live from the Duke Marine Lab at the beach in Beaufort, North Carolina. Let's learn a little bit more about Stephanie with this short video.
I'm Stephanie Weir, and I help nature work by helping to conserve coral reefs. Coral reefs are like a factory. They provide food, they provide fish, and they provide jobs. They produce, and they produce a tremendous amount for many people across the planet. I'm a marine biologist now, but I was always interested in all aspects of nature. I remember back to my earth science class in 8th grade or 9th grade, I think. And I remember plate tectonics and just being blown away by the fact that we were sitting on these massive moving land masses and that it was all being driven by heat coming from the core of the earth. I think we should care about science because it's the way we're going to figure things out. It's the way we're going to solve the problems that we're facing today.
Hello and welcome, Stephanie. It's so great to have you with us.
It's great to be here. Thank you.
So was that you snorkeling in the video that we just saw?
Indeed it was. I was snorkeling over the coral reefs in Palau, one of my absolute favorite places to be on the planet.
Awesome. I can't wait to hear more about you, your work, and coral reefs. We'll get to that in just a bit as this field trip goes on. But now it's time to introduce our participating classroom. Also joining us today are the 5th graders at Betty Weaver Elementary School in Midlothian, Virginia, and their librarian, Laura Ivy. Let's say hello to them. Let's go on a dive into a video to see some of the exotic life that we're going to learn about today. Welcome to the majestic coral reefs. Wow, that was so beautiful. So Stephanie, this is what you study, right? This is what you get to see every day.
Yeah, well, I wish I got to see it every day. Unfortunately, I do spend some time in the lab and at my computer, but it is a place that I've spent a lot of time, and it's really one of the most beautiful places on the earth.
So what's it like to dive and explore a coral reef?
It's really kind of an otherworld experience. You know, we're terrestrial creatures. We live on land. So you're kind of going into a whole new world where you are the guest, ultimately. And I think that I just see it each time as an opportunity to discover something new and to learn something new.
So when you're exploring a coral reef, what are some of your favorite things to find?
So I have a thing for cephalopods, which are, cephalopods are like octopus or squid. I just find them to be fascinating. They're incredibly intelligent. And I'm always on the hunt for an octopus lair. And you can find an octopus lair fairly easily because they leave their garbage about. Once they've had a meal, they've eaten some kind of snail or clam, they leave it outside of their lair. They've basically got a garbage pile. So when you're on a reef snorkeling, look for those little holes with garbage piles out front, and you're sure to have found an octopus lair. And they're usually somewhere nearby.
Stephanie, I understand that coral reefs can be compared to a big city under the water. What city would you compare them to, and why?
So I always think of coral reefs as the New York City of the oceans. It's where all the action is. You've got the hustle, the bustle, the neon lights, literally neon lights. You might have seen some of them in the video that we saw at the beginning. There are fast food restaurants, apartment buildings. It's really where all the action is. It's actually quite noisy. Even as a person underwater, you can hear snapping and grinding and crunching going on the reef. It's where 25% of the ocean life is concentrated. They all use coral reefs, all these animals use coral reefs as habitat or a place to get food. But it's also really important for people. The coral reefs provide food to about 500 million people around the world.
So what's so special about these coral reefs? Why is it that we see all this amazing life concentrated just on these reefs?
Well, they're coming for home, for space, and for food. So coral reefs have incredible structures. Think about the architecture of a city. Coral reefs have really crazy, amazing architecture. You've got towers and pillars and boulders the size of small cars. So there's all this space for these animals to live, to hide, to have their babies. But most of all, it's where everybody comes for food because it's just a major attraction. When you have structure in the ocean, you're always going to find animals around.
So tell me more about coral, right? So coral reefs are made of coral, but what is it exactly? Is it a plant? Is it an animal? It looks kind of like a rock. What is it?
So when you see a coral for the first time, you think it's probably like a colorful rock or maybe a strange looking plant. I mean, they come in all different shapes and sizes. So the possibilities are really endless. I couldn't describe a single particular type necessarily. But what a coral is really, really bizarre compared to any other living form on the planet. It is an animal, but it lives over basically what looks like a rock. So corals are these tiny little colonial animals. They're tiny little polyps that look like an anemone. We saw one of those out at the beginning as well.
Yeah.
But they're all connected to each other by this connective tissue. It's spread over the rock, but that rock is actually layers upon layers of the skeletons of their ancestors. So these little polyps secrete calcium carbonate or limestone ultimately. And when they die, they leave their skeleton and then a new generation grows over top. So you can imagine how slow this is, centimeters a year that they grow. So you can actually take 1,000 years for a coral to get as big as a boulder the size of a small car. So these are extraordinarily slow growing. But the cool thing is so it's an animal that sits inside of basically a rock that it created, but it also has tiny plants inside. And those plants give it the color, all that vibrant color that you think of when you think of a coral.
So corals, they make sort of a shell for themselves that's essentially made out of rock, right?
Basically, yes. So it's limestone, and they make their own home, basically. So it's pretty bizarre. You've got an animal inside of a rock with plants inside of it. So you've got the whole mix, but ultimately it's an animal.
So you mentioned earlier that there are all of these different types of organisms on a coral reef, and a lot of them are attracted to the area because there's food there. A lot of feeding goes on coral reefs. Tell me more about that.
Someone is always eating on the coral reef. Someone is absolutely always eating. The coral reef food web is very similar to a food web on land. Everything is connected to everything else. And a food web, if you don't know, is basically it explains what eats what. And it all starts with plants. And that is the basis that is the beginning of the food web, anywhere you go.
Where do the plants get their food?
So they actually get their food from the sun through photosynthesis. They manufacture food by using the sun's light, water, and they produce their own carbohydrates. So those are called primary producers. And in the ocean and on a coral reef, those are called phytoplankton and seaweeds. Those are the primary producers mainly on a coral reef. And the primary producers feed the primary consumers. So this gets a little confusing, but primary being first. So
Okay.
they are the first, the primary consumers, or primary producers produce the food. The primary consumers eat that main food. And those are the plant eaters. So they could be herbivores or they could eat other things as well. They don't have to be strict vegetarians, but they eat the plants. And then the primary consumers are eaten by the secondary consumers. And so those are the guys that eat anything else. It could be a big shark, it could be a small snapper, an eel, a stingray, and we're actually secondary consumers.
So, something that really interests me is thinking about how all of these organisms interact with each other, how they're related. You talked about the food web, one thing eats something else, which eats something else. So there are a lot of interactions that are taking place on a coral reef. I understand that there's a word, symbiosis, that talks about the relationships between organisms.
Right, so symbiosis is actually, you've defined it pretty well. It's an interaction between two different organisms, that's two different species, and they generally they're living together and often touching each other. And the relationship between them can be positive or negative, it totally depends. An example for people is actually not so great for people. It's parasitism and lice. So for those of you in school that have experienced this, I think many people have. It's not a fun experience for people, right? Lice are really miserable for us to experience. It's negative for us. But for the lice, they're getting food, they're getting a place to live. It's a positive relationship for them until we get the knit comb out and start removing them. So that would be an example of symbiosis. On a reef, there's all kinds of different types of symbiotic relationships. The most important relationship on a reef, in fact, is symbiotic. It's a mutualism.
So what's a mutualism then?
So a mutualism is a positive relationship, meaning that both organisms benefit from the relationship. So the most important relationship on the reef that I was referring to is that between corals and zooxanthellae. Those tiny plants that I mentioned live inside of them. The coral, it acts as a host to those tiny plants, and it actually provides them some of the things they need for the photosynthetic process. The tiny plants, the zooxanthellae, provide food to the corals. And corals can feed themselves, but they're not very efficient feeders, so they can get a little bit of bits and pieces from the water column. But if they don't have those tiny plants inside of their tissues providing all of that food, they'll starve after some period of time, several weeks. They require those plants to be inside their tissues. So without this relationship, you actually will not have coral reefs, which is pretty crazy to think about.
That is really crazy. So this is an interaction that benefits both of the organisms, right? So the coral are providing homes for the zooxanthellae, so that's what's good for the zooxanthellae. And then the zooxanthellae, are creating food for the coral. So they're both benefiting, right?
Exactly. It's a very happy relationship between them, and many other animals, millions of other organisms benefit from this particular relationship because it creates the coral reef.
Are there other examples of mutualism on the coral reefs?
You know, there are tons of examples. There's one that I studied in graduate school that's one of my favorites. Mutualisms are kind of my favorite relationships because I love when there's a positive in general.
Yeah.
But so there's a situation on coral reefs where, well, it's the relationships between corals and herbivores, which are the plant eaters that I was mentioning earlier, those primary consumers. And on a coral reef, there is actually this battle going on all the time between corals and seaweeds. and they're fighting for space and light, right? Because they both need light for photosynthesis, and then they both need space to grow and have elbow room to get out there and grow. So you can imagine seaweeds, weeds, right? They grow fast, and they can grow much faster than those slow corals that are just sort of inching their way up, but barely. I mean, it's barely even that. They're growing so slow. So seaweeds can easily overgrow the corals. But corals have this army of allies on the reef, herbivores. And they act as the landscapers, as the lawnmowers, and they come along and basically keep all that seaweed in check so that it doesn't overgrow the coral. My favorite thing, and this is really new science, is that there's chemical warfare going on. So when a coral detects this invasion from the seaweed, it sends out a chemical signal into the water column. And within a few minutes, these tiny little fish that use this particular coral as their home show up and start chomping at the seaweed, and not even eating it, they're spitting it out. They are doing their job clearing the coral from the seaweed. So that, if the relationship here, if that it's not clear, is that the coral is benefiting by having the fish around to keep everything in check, but the fish are benefiting by having their home. They're helping to maintain coral dominance.
So the corals send out this sort of distress call, and the herbivores hear it, and they come and they are doing what they can to protect the home that they live in, right?
Exactly. They're like the seaweed police.
That's so cool. That's so cool. So what are some other examples of mutualism on the coral reef?
So, you asked about what kind of weird things I look for when I'm on the reef. The other thing I'm always on the lookout for, and this one's a little harder to find than an octopus lair, but it is a cleaning station. But I think of it as the underwater car wash, basically. And everybody, including me and you, have to get clean sometime. And fish are no different, right? And so you get these big fish, and they line up at the cleaning station. They literally take their place in line, and they wait. And when they get to be their turn, out pops these tiny little cleaner fish and cleaner shrimp. The big fish opens its mouth, so it just opens and just sort of sits and waits. And in come the tiny shrimp and the tiny fish, and they eat up the dead skin and the parasites from inside the mouth and in the gills. They basically clean up the whole fish so it's happy and healthy, and it goes on its way. And those little cleaners basically get their meals, so they're also getting their food from this. If you think about it, it requires a tremendous amount of trust for those shrimp and fish to enter the mouths of these bigger predatory fish in many cases.
Are you brave enough to put your head into the mouth of a big fish?
I would absolutely not put my head into the mouth of a big fish. I would probably happily let a cleaner shrimp clean up my hand or something like that. But no, I don't think that's advisable at all.
So the cleaner shrimp and the big fish that they're cleaning, are they predator and prey elsewhere? Like when they don't run into each other at a cleaning station, would it be possible for one of these big fish to eat the cleaner shrimp somewhere else?
Yeah, that's the crazy part, is it's kind of like this social contract. There's this level of trust where they know that they're there for a purpose. But anywhere else on the reef, you're fair game. So it's pretty amazing, actually, how it works.
That's fascinating. So the cleaning station is like a neutral area where the two of them can work together, but elsewhere they might be predator and prey.
Exactly.
So we got a couple questions for you. The
Okay.
first one comes from our participating classroom.
Hi, I am Ryan, and my question is, are coral reefs found only in the tropics?
So Ryan, thank you for your question. That's a great question. Yes, coral reefs are found only in the tropics. As Tyler was saying at the beginning of our broadcast, they require warm water, a minimum of 70 degrees Fahrenheit. So you have to be in a place with warm water. You can find corals in other parts of the world, but they don't form reefs. And you also can find reefs in other parts of the world, but they're not made up of corals. So I think where you are, Tyler, in Virginia, they have oyster reefs off the shore there, but they don't have coral reefs.
All right, so Stephanie, our next question is about jellyfish. How much do you know about jellyfish?
I've actually swum with some jellyfish in that video, so I've had some close-up encounters, but let's see.
So here's a question. The question is from Nikki.
Okay.
And Nikki asks, do some jellyfish not sting?
In fact, those jellyfish that we saw at the very beginning of the broadcast were stingless jellyfish. So, well, they have stingers, but we don't feel them. So you saw all those people, there was a couple of people swimming through clouds of jellyfish. That is not something I would typically advise to do, but there are places in Palau, and those were in the jellyfish lakes of Palau, where you can do that. The stingers don't cause any pain.
All right, Stephanie, the next question, this question is about you. And Carrie asks, when did you start to study coral reefs?
So I actually didn't start to study coral reefs until the end of college or graduate school. I was studying all kinds of other things up until then. I was really interested in science and nature and people, but I wasn't quite sure what exactly I wanted to do. And so I didn't happen upon coral reefs for quite some time. I was probably 23 before I saw my first coral reef in person.
And what got you excited about studying them?
And like I said, I've always had this love of nature and science and being outside. And I think that, you know, I sort of took a serendipitous route. It wasn't a very planned route where I found myself in coral reefs. And honestly, I was looking at different graduate schools and different programs. And to be completely honest, one of my prospective advisors, because when you go to graduate school, it's all about the person that's going to be your mentor, asked me, hey, Stephanie, if you decide to come to my school, would you be available to go to the Florida Keys this summer to work? And that kind of was it for me. I thought, yeah, I'd definitely like to go to Florida Keys this summer. And that was how I made my decision. It sounds kind of shallow, but it's served me really well since then.
And sometimes the choices that we make in life, we have no idea where they're going to take us.
Exactly.
So tell me more about these interactions on a coral reef. How do fish and other organisms tell each other apart? I understand that chemistry plays a role in this.
I think of chemistry as the language of life on a coral reef. You think about, we can smell things the same way that organisms on a coral reef sense things chemically. So we know if it smells good or bad, or if we remember it from some other time when something happened, you know, sort of a nostalgic smell. But the animals are the same. Now, you think about a coral, it doesn't have eyes or ears. It can't see what's going on. So it uses chemistry to communicate. It needs to know if its neighbor is its next meal or its next mate. If you can't see, you need to know that what you're eating isn't poisonous. So you're making really big, almost life or death decisions based on the chemistry that all of these different organisms are producing.
So we know that a lot of the chemical compounds that are found on coral reefs are sort of unique. The organisms on a coral reef have to deal with environments and challenges that we might not have to deal with on land. And is that so?
That's right. It's just like a plant or a tree. They have to protect themselves in some way because they can't run away from a predator, so they produce chemical compounds to protect themselves.
Tell me about the ways that scientists and others are able to use these chemicals from the coral reefs for more than just the purposes the organisms are using them for.
Right. So this is really pretty cool stuff, and it's been going on for a while. But we scientists, collective we, have been taking the chemistry, the chemical compounds that these different organisms produce, and turning them into medicines for people. So if you've ever known anybody that's had leukemia or lymphoma, they have likely been treated by a drug that comes from a reef sponge in the Caribbean. There are also drugs that are used to treat pain, different types of viruses. There's even stuff coming from reefs that are used in sunscreens.
Sunscreen?
Yeah, so you think about those animals also need to protect themselves from radiation from the sun, and scientists have been able to take that chemistry and turn it into something that we can use to protect ourselves from the sun.
That's fascinating. And so that in itself is a great reason why it's really important to conserve these coral reefs, because they are tremendous sources of chemicals, and who knows what the next chemical discovery could help to cure.
Exactly. We don't know. We call them the medicine chests of the sea, and there's so many medicines that we haven't even discovered yet. So it is one of the reasons why we should make sure that we take good care of coral reefs.
So we've got many potential medicines that could come out of the chemicals used on coral reefs. What else can coral reefs do for us?
Coral reefs also protect shorelines. So you've heard probably of the Great Barrier Reef. It's it's the largest, I think, living feature that you can see from space. You can actually see the Great Barrier Reef from space, which blows my mind. And it is called the barrier reef because it acts as a barrier to all of those waves that would otherwise be crashing against the shore. That reef crest, which is the highest part of the reef, breaks the wave energy, and so it fizzles out once it passes the reef crest and protects the shoreline. It actually makes it possible for people to live in coastal areas. There are 200 million people that are protected by coral reefs globally.
So let's get some questions about this stuff.
Hi, I'm Ava, and my question is, coral reefs are effective natural barriers in preventing erosion. What is the opinion among oceanographers regarding artificial reef construction?
So that's a great question, Ava, and I'm going to give you an answer that you'll hear from a lot of scientists when you ask a question, which is we're not sure yet. So this is something that we are looking at really carefully, and there are studies going on all across the world trying to figure out if this is a good idea and if we can actually do it. There are many places where reefs need a boost, especially in those places where you've had a big ship grounding or there's been some physical damage to the reef, and that reef was providing important protection to a coastal area or maybe providing food and livelihoods to the people that live there. So we're trying to figure this out right now, but I would have to say stay tuned. I think it's probably a good idea, but we're not quite sure yet.
I have a question for you. What advice would you give to young people who are interested in marine biology or in studying coral reefs? What should they do to learn more about the topic?
In terms of learning about marine biology, I think you need to just start wherever you are. I don't think you necessarily need to dive into marine biology at first. Understanding where you live, understanding the nature around you is so critically important for developing your critical thinking skills and your observation skills. I have a 5-year-old and an 8-year-old, and one of the things that I do with them is whenever we go places, I give them a journal and I ask them to make observations, to draw things that are interesting to them, and sort of keep track. And I think doing that really fine-tunes your observation skills, because to be a good marine biologist, you have to make really fine-scale observations to sort of figure out what's happening around you.
All right, so here's a question from our live audience. Elise asks you, if the coral is an animal, why doesn't it move?
Well, not all animals move. Some are called sessile. Then by definition, that means they're stuck to the ground. But in fact, corals do move. If you were to see the polyps extend their bodies out into the water, they flow and they can control their movements. To some degree, they also just flow because the water is moving quickly. But they do move.
Here's a question from Mrs. Moore, and she asks, we are 5th graders in Wyoming, a landlocked state. How can we do our part to help protect coral reefs?
So that's a really good question, and I think being in a landlocked state doesn't really put you at a disadvantage. I always like to think about the quote from Finding Nemo. I hope most of you guys have seen it. It's definitely one of my favorite movies, where they say, all drains lead to the ocean. And this is absolutely true. No matter where you live in the US or elsewhere, that water that you're putting down your sink, down the drain in your kitchen, is going to end up in the ocean at some point. It may flow to a river first, but those rivers all flow into the ocean. So it's really important to think about what's going down your drain. It's also really important to think about what's happening in your yard. If you have a yard where you have a garden, maybe grass, fertilizers are not good for the reef. They're not good for the ocean. Pesticides are also not good for the reef or the ocean. So thinking about what you do on land is really, really important. Also, my guess is maybe even in Wyoming, there are seafood restaurants. And one thing that I encourage people to do, no matter where they are, is to always ask where their seafood comes from, and to make sure that that seafood is what we call reef safe or sustainable, meaning that the way it's being fished is not harming the fish population or their habitat. And there are some really great guides out there to help you, because we don't expect people to be experts on fish. There's an app called Seafood Watch, and that's put out by the Monterey Bay Aquarium, and I really encourage people to use that as a guide whenever they are dining on seafood.
I got a question for you, Stephanie. We talked earlier about all of the interactions that happen on a coral reef, and particularly the delicate interaction between zooxanthellae that live inside the coral. I get the sense that these are delicate interactions, and they could get threatened in certain ways. Are there ways that this important balance can get thrown off? Can coral reefs get sick?
So everything in life is about balance, I think. And corals are extraordinarily sensitive. So we've talked about the fact that they can only live in warm water, but it can't be too warm. And they need lots of light for photosynthesis, but not too much light. And they also need clear water. So that's why it's important not to be putting fertilizers and toxins down your drains and into your yards. So when you add those things to the mix, you can really set the balance off, and corals can get sick. The biggest threats to corals, when we sort of lump them all together, because there are many different activities that threaten corals and the ocean in general, we think about overfishing, so that's taking too many fish out or destroying the habitat that those fish live in. Mm-hmm. And that you can imagine if you, for example, took too many herbivores, those plant eaters, the seaweeds would overgrow the corals. Then there's pollution. I've talked a little bit about that with taking care of your lawn. There's also sewage pollution. There's a lot of parts of the world where they just dump raw sewage, meaning nothing has been done with it. It's like in the toilet, out onto the reef. That pollutes the reef and causes problems. And then we've got issues associated with climate change. And that causes coral bleaching.
What's coral bleaching? Is it like they're getting a sunburn?
Well, sort of. They are kind of getting a sunburn. They're getting too much light, but ultimately the big problem is it gets too hot. And so with climate change, we're seeing big shifts in temperature, and most of those changes have been occurring in the ocean. So the ocean has been absorbing the heat that people have been talking about. So we haven't experienced it as much on land yet. It's more being absorbed into the ocean. So in the tropics, the water is warm already, but it gets even warmer. And when it gets too warm for coral reefs, it stresses out that relationship, actually, that we talked about earlier between corals and the tiny plants, the zooxanthellae. And the zooxanthellae get out of there. They get kicked out. It's no longer a happy relationship. And so it's called coral bleaching because those plants give the coral all the color. So when they bleach, they're just completely white. They don't have any of their, what we call symbionts, those little plants, in their tissues. And they can't live very long like this. So I had said that they depend on these plants for food. So if it goes more than a few weeks, they can actually come back into the bodies of the corals. They call that reassimilation, bringing the zooxanthellae back. But if that doesn't happen, if it stays hot and the conditions stay stressful, then the corals will die.
So a lot of the coral reefs that we've been talking about exist in the small island nation of Palau. And I know that about 20,000 people live there. What's their relationship to the coral reefs?
So corals are found all over the world through the tropics. There's 80 different countries that have coral reefs. Palau is a particularly special place to me. I've been working there off and on for the last decade. And they have particularly special coral reefs. They're actually called one of the 7 underwater wonders of the world. The people of Palau are deeply connected to coral reefs and the ocean. So they come from the water. They, about 5,000 years ago, their ancestors came over in canoes from Malaysia, Philippines, Indonesia, coming by water across massive distances of ocean to settle in Palau. So they're people of the water, really. They also live on coral reefs. So the islands of Palau are uplifted coral reefs. They were pushed up out of the water through crust movements of the Earth's crust. And there are some parts of the reef that are 300 feet up in the air. So they actually live, their homes are on top of reef. It's dry land at this point. But then they're working on the wet reef, working in getting their fish and maybe tourism and whatnot. They're getting a huge part of their culture is associated with coral reefs. So Palauans and coral reefs, are intertwined completely in their existence, and they depend upon each other.
So the Palauans depend on the coral reef. What are they doing to help protect it?
Palauans are kind of amazing in terms of what they're doing to protect their natural resources, and specifically their coral reefs. They're global leaders in sort of the trailblazers ultimately in what needs to happen to best protect your marine ocean resources. There's two things that they're doing that I find particularly inspiring, and so have others. Others have actually followed their lead. The first thing they did is they set Palau as the first shark sanctuary in the world, which means that they don't fish shark in Palau, and nobody is allowed to fish shark in Palau. And this is a pretty big deal because even though I think sometimes people think sharks are these big scary creatures, they're really not, and they're extraordinarily important for the ocean food web and for overall ocean health, and especially on coral reefs. They're the top predators on a reef, and you need sharks. And sharks are targeted for particular parts, body parts, shark fin soup and things like that. So there's been a lot of pressure on sharks. So that's a really big deal that Palauans have done that. The other thing they're doing, and they're in process, is they are closing all of their waters to commercial fishing, which is a huge deal. Historically, or in recent years, I guess, boats from other countries have been paying a fee to come and fish in Palau's waters, and they just take lots and lots of fish and they leave, and the Palauans aren't benefiting from the fish, which they depend on. So they have decided that this is not a long-term, as we use the term, sustainable, meaning it can't go on forever without causing some harm. It's not a good thing for Palau. So they're now switching to just local folks that want to go out on the weekends, the local fisherman that's feeding his family. That's going to be allowed, but no other fishing is going to be occurring in Palau. It's going to take a few more years to put it into place, but it's pretty exciting stuff.
It's so inspiring to hear about a small group of people who are really committed to conserving a really important part of the environment. So we have time for a couple more questions. This one comes from Kaylee, and Kaylee asks, how large can a coral reef be? What factors determine the size of a coral reef?
Wow, that's a really good question, Kaylee. So a coral reef can get really big. I mean, the Great Barrier Reef could be considered one whole reef, and that stretches, I want to say, something like 1,500 kilometers. But gee, I'm afraid to say that with that. That could be wrong, but it's about the size of Japan, I think, in terms of length.
Oh, wow.
So we're talking about huge, huge areas, right? All of the coral reefs in the world could actually fit into the state of Arizona. So if you go and look at a map and find the state of Arizona in the US, you'll get a sense of how much reef is actually out there. But what determines it is going to be, are the conditions healthy? Do you have enough light? Do you have the right temperature? Do you have clear water? Do you have shallow enough water? Because coral reefs don't grow after the light disappears. So when it gets dark, you stop seeing coral reefs. And you need enough flow of water. And then you need a supply of babies. So that's really important. And in our conservation work, we think a lot about where the babies are coming from to make sure that if we're setting up a protected area, for example, there's a source of babies that are going to come in and settle, basically make their homes on the ocean bottom. So there's a lot of things that determine how a coral reef grows and how big it gets.
I have one quick question for you. Stephanie asks, can we eat corals? Are there any edible corals?
Stephanie asked that question, huh? Okay, Stephanie, that's a good question. I'm going to say no. I have not heard of anybody eating corals. They probably wouldn't taste very good because you think about it, it's just a very thin, kind of mucousy layer of tissue on top of some really crunchy calcium.
Ah, yeah, that would be hard on the teeth.
But I will tell you a funny story about, just a brief story about who does eat corals and what it turns into. So parrotfish, named parrotfish because they have a beak that looks like a parrot, they eat corals and they chomp down on the tissue, but they always get a bit of the reef, of the calcium carbonate, that limestone below, and they poop it out and it turns into sand. So if you're ever on a beach in the tropics, you can be assured that you are hanging out in parrotfish poop.
Wow. That's fascinating. So anyway, we're just about out of time. Today, we've seen some awesome stuff. We've seen how the coral reefs function like an amazing underwater city, with each creature having an important role that benefits the whole system and people as well. It's important that we remember that nature works hard, and so we must work hard for nature. So a big thank you to our scientist, marine biologist Stephanie Weir. I've learned so much from you today. It's been an absolute pleasure.
Thank you. I've had a great time, Tyler.
And thanks so much for joining us, Betty Weaver School. We really appreciate that you took the time to ask some questions and join us. And thanks so much to all of you viewers for watching our episode. Goodbye.